Time travel. Friends, this is a topic that everyone finds exciting. You might have heard that through a black hole you can time travel to the future, or if you travel at nearly the speed of light, you can also time travel to the future. Friends, but the question is, what is the reason that causes time to slow down near a black hole? Or why does time slow down when traveling at nearly the speed of light? And through both these methods, you can time travel to the future. And if you move at 100% of the speed of light, time will completely stop for you. Friends, if you think about it, time travel is nothing but time dilation. That is, the difference in time between any two places in the universe. Now, friends, what is this time dilation? And why does a black hole slow down time? And why does time stop when moving at the speed of light? Let's understand it in detail. Hello, friends. Welcome to this video. Friends, before understanding what time dilation is and how time travel can be done through time dilation, it is essential to understand time itself. Friends, let me ask you, what exactly is time? Is it the ticking of a clock moving forward? Is it the changing of dates, months, and years in a calendar? Think for a moment. Thousands of years ago, there was a time when there were no clocks or calendars in the world, yet even then, people felt the passage of time. Today, we have bound time to clocks and calendars. So, friends, is this really time? No, what we call time is actually not time at all. It is our illusion that we have bound time to clocks and calendars. But the truth is that time has bound us, not the other way around. If you think about it, the ticking of a clock does not make us feel the passage of time. Rather, change makes us feel the passage of time. It would not be wrong to say that change is what makes us experience time. For example, a small seed germinates into a plant, and that plant one day transforms into a giant tree. Friends, the transformation from a seed to a giant tree does not happen overnight. It has a complete journey, and this journey progresses through a momentary present. For that tree, this journey is the experience of time. Friends, we divide this journey of change into three periods: past, present, and future. The past is when entropy in the universe was very low. At that time, everything in the universe was in order. The future is when the disorder of everything in the universe will increase and entropy will be at its peak. The present is the momentary point where we feel the change from order to disorder. Friends, think of the present as a boundary where the future continuously converts into the past. For example, right now you are watching this video. This very moment is the present. The present is the moment where reality actually exists. But this present does not last long. In a moment, it becomes the past. Friends, past, present, and future are essentially the flow from low entropy to high entropy, which you can call time. And this flow of time always moves from the past to the future, which is also called the arrow of time. So, friends, time is nothing but the change occurring in the universe, and we feel the passage of time by observing change. If this change stops, time will also stop. Now, friends, humans invented clocks and calendars to measure these changes in the universe, so that we could measure the daily events occurring in the universe. Now, friends, as we have learned that change is time, let me tell you that this process of change is not happening at the same speed everywhere in the universe. In some places, the speed of change is fast, while in others it is very slow. In other words, the pace of time is not the same everywhere in the universe. In some places, time moves faster. In others, it moves slower. Friends, the difference in the speed of changes occurring at any two places in the universe is called time dilation.
Let's understand this in simple language.
Suppose there are two planets. One is our Earth, and the other is an alien planet orbiting a black hole. Now imagine a seed is planted on both planets. The tree that grows from this seed has a lifespan of 100 years. That means changes occur in the tree for 100 years, and after 100 years, the tree dies. If we plant both seeds on Earth at the same time, the trees will grow together and end their lives together. This happens because the speed of change on Earth is the same for both trees. Now consider another scenario. The same two seeds are planted simultaneously on two different planets. One seed is planted on Earth, and the other is planted on the alien planet orbiting a black hole. In this scenario, the speed of change is faster on Earth and slower on the alien planet orbiting the black hole, because the high gravity of the black hole slows down all changes on that planet. So here's what will happen. Trees will grow on both planets and complete their 100-year lifespan. However, the difference will be that by the time the seed germinates on the alien planet orbiting a black hole, the tree on Earth will have already grown from a seedling into a large tree. And by the time the seed on the alien planet becomes a seedling, all changes in the tree on Earth will have ended and the Earth's tree will have died. As we just learned, due to the high gravity of the black hole, the speed of changes on that alien planet is slower. So it will seem to us that time is moving slower on that planet compared to Earth. In reality, time has not slowed down on that alien planet. Rather, the rate of change there is slower compared to Earth. This is why the passage of time seems slower there. Now here's the interesting part. If you yourself were to reach that alien planet, your body would also occur at a slower rate. For example, your heart rate would slow down, blood flow would slow down, meaning your age would pass at a slower rate. But this does not mean you would see everything around you in slow motion. No. Just as you see everything normally on Earth, you would see everything normally on that alien planet. You wouldn't even realize that the rate of change is slower for you. However, in reality, if you look toward Earth, it will seem to you that time is passing faster on Earth. Meanwhile, a friend of yours on Earth would see that time is passing normally for them. But if your friend looks at you on the alien planet, they would see that time is passing very slowly for you. Your friend would see you moving in slow motion. Friends, this is called time dilation. You might have seen the movie Interstellar. In it, Miller's planet, which orbited a black hole, had 1 hour equal to 7 years on Earth. This means, friends, that time is not a universal clock that ticks at the same speed for everyone. There is no master clock in the universe that ticks the same for all. The passage of time depends on the observer's perspective. Friends, gravity slows down the passage of time. This leads to the fascinating concept of time travel. Suppose you use a wormhole or teleportation to go to the event horizon of a black hole and spend 1 hour there before returning to Earth. You would find yourself in the future on Earth because only 1 hour passed for you near the black hole, but many years passed on Earth. Friends, this would be your one-way ticket to the future. In this way, you can travel to the future, but you cannot return to the past. Friends, this is called gravitational time dilation.
Friends, time dilation in the universe does not only occur due to gravity, but also due to traveling at high speeds. For example, if you build a spacecraft that travels at nearly the speed of light, the passage of time will slow down for you. If you travel in that spacecraft at nearly the speed of light, it will seem to you that time is passing normally. But when you look toward Earth, you will see time passing faster on Earth. Meanwhile, your friend on Earth will see that time is passing slower for you. Your friend will see the time inside your spacecraft passing in slow motion. If you travel at 99.9% of the speed of light for 1 month and then return to Earth, you will find that many years have passed on Earth. For you, only 1 month passed, but many years passed on Earth. Friends, this is called relativistic time dilation. Now, friends, the question is, why does time slow down due to gravity, and why does it slow down when traveling at the speed of light? First, let's understand relativistic time dilation. Imagine a light clock with 2 mirrors, one at the top and one at the bottom, between which a light photon oscillates. Suppose the light reflects from the bottom mirror, hits the top mirror, reflects again and hits the bottom mirror, completing this cycle in 1 second. Now, friends, as the spacecraft's speed increases and approaches the speed of light, your friend on Earth will see the light clock in the spacecraft oscillating in a diagonal path. However, for you in the spacecraft, the clock will appear to oscillate normally in a straight line, so time will seem normal to you. But your friend on Earth will see that the light in your clock has to travel an extra distance to reflect between the 2 mirrors. As we know, the speed of light is constant in the universe. So, from your friend's perspective, the light will take extra time to travel that extra distance. This means that for you in the spacecraft, 1 oscillation will take 1 second, but for your friend on Earth, the same oscillation will take more than 1 second. Thus, for you in the spacecraft, time appears normal to you, but for your friend on Earth, time appears to have slowed down for you. Both will feel their own time passing normally, but when observing each other, you will see your friend's time passing faster, and your friend will see your time passing slower. Friends, this is called relativistic time dilation. Now let's understand why gravity slows down time. Friends, let me ask you, in what medium was your spacecraft traveling at nearly the speed of light? You might say it was traveling in empty space. But friends, this is incorrect. Your spacecraft was not traveling in empty space, but in space-time itself. Friends, space-time is a 4th dimension where time and space are not separate but the same thing, and space-time itself is not an empty place but a physical entity. Friends, I have explained what space-time is in detail in my video on gravity. I want you to watch that video after this one so you can understand things better. When the spacecraft travels through space-time at nearly the speed of light, your friend on Earth sees time passing slower inside the spacecraft. Similarly, gravity also slows down time. The gravity of an object causes space-time to curve toward the center of that object. As we move away from the object, its gravity weakens. Look at this animation. Near the planet, space-time flows rapidly and curves toward the center. But as we move away from the planet, the flow of space-time slows down. Now, friends, understand that light always travels through this space-time. If we place the same light clock near this planet, we will see that due to the flow of space-time itself, the light appears to oscillate in a diagonal path. Light travels through space-time, but space-time itself is moving forward. This is why gravity slows down the passage of time. As you move the clock away from the planet, an observer in space will see that as you move away, the flow of space-time slows down, causing the light to travel a shorter distance to oscillate. This means the passage of time becomes faster compared to before.
Friends, this is called gravitational time dilation. The stronger the gravity of an object, the slower time passes on that object. In the universe, a black hole's gravity is so intense that it affects time significantly. It is believed that at the singularity of a black hole, time stops completely. This happens because the flow of space-time at the singularity of a black hole occurs at the speed of light. Now, you might wonder, if space-time flows at the speed of light, why does time stop? To understand this, you need to travel in the same spacecraft that was moving at nearly the speed of light. Friends, understand one thing. Nothing in the universe can travel faster than the speed of light. Practically, only massless particles can travel at the speed of light, and photon particles are massless, which is why they travel at the speed of light. If you noticed, I always say that a spacecraft traveling at nearly the speed of light will have some mass, so it cannot travel at the speed of light. But friends, in our imagination, let's assume the spacecraft is traveling exactly at the speed of light. In this scenario, an exciting event will occur. When your spacecraft travels at 100% of the speed of light, your friend on Earth will see that the photon particle in your light clock is not oscillating, but traveling in a straight line parallel to your spacecraft at the speed of light. This means your friend will see that time has completely stopped in your spacecraft. So, at the speed of light, time stops completely. And something similar happens at the singularity of a black hole. I hope, friends, you have understood the concept of time dilation. Friends, to understand why and how gravity affects space-time and what gravity actually is, you should watch the video shown on the screen. This video will completely change your perspective on the universe. If you liked this video, please like it and subscribe to the channel for more exciting videos.